Now, since we have learnt about drag force, it's time to do a couple of numerical problems on that topic and see if we can apply our formulas correctly in solving them. So here is the first problem for us. I shall number the question 1 and read it. A body of mass 1.10 kg falling from rest under gravity experiences a drag force of 4 V Newton, where V is its speed in meter per second. Find the terminal speed of the body, the time constant of its motion, speed after 0.1 second, and time after which the speed becomes 2 meter per second. So you can understand, in this case the body is falling through atmosphere and the drag force exerted by the air, and they are telling us the mass of the body is 1.10 kg and the drag force exerted upward by air as it falls under gravity is given by an expression of the type 4.00 V Newton. Now look at the expression. They are telling V is the speed in meter per second. So recalling what we have learnt earlier, that when the drag force varies linearly as speed in case of low speed motions, we have found an expression Fd equal to B into V, where B is the proportionality constant. So if we compare these two formats, is 4.00 V Newton and here B into V, we identify that B, the constant proportionality, this B is nothing but 4.00 Newton second per meter. Look at this unit of B and you must confirm that the value of B is coming out to be 4 Newton second per meter. Once again, I emphasize that you must confirm that the unit of B is this. Now with this, let's proceed and do the different parts. Part A asks about terminal speed of the body, and you are aware that Vt, terminal speed, is given by the formula mg by b. Of course, in the motions where drag force varies linearly as speed and the other propulsive force is the gravity force. So here we put the values. M is 1.10 kg. The value of G we put 9.80 meter per second square. The value of B has been found just now by comparison with the given data, 4.00 Newton second per meter, and calculate this to show the terminal speed Vt is coming out to be 2.70 meter per second up to 3 significant figures. That is the first part of the problem. In part B, they are asking about time constant for its motion. You are aware time constant formula in motion of this type, where the gravity force is the propulsive force and drag force varies linearly with speed. We found earlier in our theory classes, this is given by time constant is given m by b, where m is the mass. So once again we put this simple data, 1.10 kg, b is 4.00 Newton second per meter, and by calculation this tau is coming out to be 0.275 second. That's time constant. To remind you quickly, this is the time over which the body gains a speed which is about 63% of its terminal speed under the gravity force and the drag force. In part C of the problem, they want us to find the speed after 0.1 second of motion, and for this we shall recall that the instantaneous speed v as a function of time is given by v is equal to vt into 1 minus e to the power minus t by tau. In the expression, you remember vt is terminal speed, is exponential function, and tau is the time constant for that motion. So we already found the value of vt in the part A to be 2.70 meter per second, and in part B the time constant tau was found to be 0.275 second. So we just put the values here. So this is Vt is 2.70 meter per second by our calculation, Then inside the bracket 1 minus e to the power minus, this is a time they said after 0.1 second, so 0.100 second is the value of t, and tau has been already found to be 0.275 second. Just look carefully that here the power of e has to be a dimensionless number, and since t by tau I write down, the seconds cancel out, is giving me a pure number, so there is no difficulty in calculation. Complete the calculation will require a calculator for this, and show this is coming out to be 0.823 meter per second up to 3 significant figures. I have highlighted my results obtained so far. We shall carry the results to a fresh page to complete the fourth part, D, of this problem. So we are on a fresh page here with the same problem, and the answers of the first three parts A to C have been written for any reference if required. In the part D, they are asking us to find the time after which the speed of the body becomes 2 meters per second, and for that we shall make use of equation that we used in part C and rearrange it to write e to the power minus t by tau. I am just making use of this equation only, but I am writing in a little different way, and that you must check yourself that you get the same thing, is coming out to be 1 minus v by vt. Okay, here tau is the time constant and vt is the terminal speed. In the next step, taking natural logarithm on both sides of this expression, we are getting left hand side simply boils down to minus t by tau by taking logarithm. On the right hand side we get log to the base e in bracket 1 minus v by vt. It follows therefore that the time can be expressed as minus tau into log 1 minus v by vt. Now let us put the values here. Minus time constant tau has already been found in part B of the problem, that is 0.275 second. So I put the value. Into log of in bracket 1 minus, they say the speed has to become 2 meters per second. That's the value of v. So we write here 2.00 meters per second is 3 significant figures divided by the value of vt terminal speed has been found in part A of the problem to be 2.70 meters per second. So we put that value as well, 2.70 meters per second. Make the calculation and show that the value of t is coming out to be 0.371 second up to 3 significant figures, and this is the time after which the body attains a speed of 2 meters per second. This is the part D of this question. Let me add just one point here. You can see the quantity inside the bracket is a fraction less than 1. So when you take the logarithm of that, this logarithm happens to be a negative quantity, and this minus, the two minuses eventually gives me a positive result as expected.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.